Like many other bimodal provinces worldwide, the volcanic rocks of Oregon's high lava plains are mainly basalt and rhyolite, with sparse intermediate compositions shown on this histogram of relative volume. How is this compositional variation formed? Let's look at the evolution of a select group of rocks by focusing on the variation of iron concentration relative to silica, shown here in two lines of descent from basalt to rhyolite. During regional extension, upwelling of the mantle is reflected in the rising isotherm. Hot solid mantle rises to lower pressure. This causes partial melting of the mantle near the base of the crust. Magma is injected into the crust, and thin flows of primitive basalt erupt at the surface. Some of the basalt, collected in small magma reservoirs, cools, and crystals separate on the way to the surface, making a fractionated basalt along a tholeiitic differentiation trend. As basalt input continues, some crystallizes to gabbro, changing the composition of the crust, warming the crust to the point where partial melting occurs. The melted crust contaminates the basalt, yielding iron-poor calc-alkaline basaltic andesite. Rhyolite magma grows from coalescing pods of crustal melt. Repeated supply of basalt magma supports continued melting and growth of the rhyolite reservoir. During thermal waning, separation of crystals in the magma chamber produces a more silica-rich, iron-poor rhyolite. As cooling proceeds, simple mixing between the basalt and the high silica rhyolite yields sparse intermediate dacites. Let's look at a variation of this scenario where there is more heat input in the way of basalt and extensive hybridization of the crust with gabbro. Persistent intrusion causes melting of the hybridized crust, which in turn causes a mushy zone that acts as a density barrier to later basalt. The long-term steady supply of heat supports the growth of a rhyolite magma chamber through crustal melting. As the system cools, fractional crystallization of the silicic magma reservoir develops a zone of high silica rhyolite. Stirring of iron-rich basaltic andesite into the iron-rich rhyolite in deeper portions of the magma chamber yields scarce mingled dacites that erupt as inclusions in the eruption. The depleted magma chamber mixes with the underlying basalt to produce another small dacite layer.